Okay. Assalamualaikum and madam. Today I will present about the title is hydraulic. So first for the introduction is hydraulic is a branch of science concerned with the practical application of fluids, primarily liquids and in motion. Hydraulics deals with such matters as the flow of liquids in pipes, rivers, and channels, and their confinement by dams and tanks. So they have two law about this hydraulic. The first one is Pascal law, and second is Bernoulli law. So the first one is Pascal law is used to gain an increase in force. A small force applied to a small piston in a small cylinder is transmitted through a tube and then to a large cylinder where it presses equally against all sides of the cylinder, including the large piston. And the Bernoulli's law is formulated about a century later, states that energy in a fluid is due to elevation, motion, and pressure. And if there are no losses due to friction and no work done, the sum of the energies remains constant. Thus, velocity energy deriving from motion can be partly converted to pressure energy by enlarging the cross-section of a pipe, which slows down the flow but increases the area against which the fluid is pressing. So this is the one of uh, picture for the Pascal's law and Bernoulli law. So for the difference between Pascal law and Bernoulli law is the Pascal law have two pistons in one tube, and the Bernoulli's law only one piston in one tube. Yeah. So uh, identify and explain one theory concept in physics that can be applied to the OSH practice in the workplace. So the theory in physics then that I can apply to the OSH practice in the workplace is hydraulic crane. So the standard in mobile cranes, hydraulic cranes are able to lift thousands of pounds using the simple concept of transmitting forces from point to the point through a fluid. They work by harnessing the strength that liquid under pressure gives. The liquid, usually a light oil or water, work with a system of pump and pistons. By moving the liquid under pressure from the pumps, pistons can be extended or reduced, and when these pistons are connected to a system of levers, the pistons can be used to lift surprisingly heavy weight. So the main use of hydraulic crane is usually used in major projects such as like bridge, building, airports, roadways, and many more. So that is a hydraulic crane as the picture. So the advantage of using a hydraulic crane is the first one is simple. They are amongst a simple system that you can use within any industrial process. Therefore, they are very easy to maintain. Second is lightweight. Most of lightweight, but they are still able to lift just as much as a tower crane. Therefore, power is not an issue. So the third one is flexible. The which ease with which they can be moved from one area to another makes them a very versatile tool with lots of uses on a day-to-day basis. And then next is compact. Hydraulic mobile cranes need a fraction of the space tower cranes need. Therefore, when there's construction in an urban area, for example, they are tight and tidy. And lastly, timely. Setup time is very quick. For example, the mobile crane can drive up, get secure and hoist its boom and begin work. This means work can begin quicker and projects can be completed faster. So the conclusion from this topic about hydraulic is this section has been devoted to an in-depth study of how to manipulate forces by controlling pressure, with a thorough understanding of the five basic pressure valve functions. The design engineer's ability to control the interaction of force is limited only by his imagination. Hydraulic systems, when properly designed, put tons of force under precise fingertip control. You should understand that no matter how complex the function, all pressure control operate by balancing a hydraulic force with a spring. This spring balancing is readily apparent in direct operate valve design, but it is also a key operating principle in pilot operated versions. The important points covered in our discussion of pressure reducing valve were: first, the relieving ability of a pressure reducing valve, and second, the differences between pilot operated version with either primary or secondary control. We also mentioned the inherent ability of the reducing valve to generate heat in the hydraulic system. The hydraulic specialist who understands pressure and how to control it, it knows just about half of everything there is to know in his field. When he combines this knowledge with the principle of flow, the designer has the world of hydraulic at his fingertips. So that's all for today. Thank you for watching my presentation.